All right, last section is step functions. So we've had piecewise functions, and step functions are another type of piecewise function. So this is called the greatest integer function. Different textbooks are going to have different symbols. Some textbooks, it's just simply like this. And it's kind of deceiving because it's just a rounding down function to the nearest integer. But it's called the greatest integer function, and it's the greatest integer less than. It's kind of confusing. So if you have 3.25, it's going to round down. If you have negative 4.6, it's going to round down. Okay? So it seems when you say greatest integer, it's actually going down. Now, the book does not discuss the other type of rounding up, rounding down function, which is this, which means rounding up. We've talked about that in class. Here we have coordinates to graph yourself. So let's talk about these numbers. How would I graph this? Let's just make an XY table and let's just pick one value. Let's talk about the number 2. If I had 2.9, 2.4, 2.3, 2.1, and 2, what would my outputs be? Well, if I had 2.9, I'm rounding down, so I would get 2. If I had 2.4, I'm rounding down, so I would get 2. If I had 2.3, I'm rounding down, so I'd get 2, 2. Well, can't round down more than 2, so it's 2. So let's go to 2.9. I'd get 2. 2.4, I get 2. I get 2. If I'm 2, I'd get 2. Okay, so this whole line is filled in. What about 3? Well, 3 rounding down would be 3. So there's going to be an open circle here. All right, so closed circle here, open circle here. If it's 3.1, I get 3. Oh, so we're going to have the same thing again. If it's 4.2, I'm going to have 4. If it's 4.5, I'm going to have 4. This whole line's filled in again. And it starts to look like steps if you fill the whole thing in. Okay, so am I going to make you graph it? No, but I want you to be aware of what a step function is and what it looks like. If you want some practice in your notes, you can go to this worksheet. Okay, and this will be your homework assignment. The top part, you're just substituting f of 2. Well, I go to the f function on any of these. My x value is 2, which is greater than 0, so my output is 2. Let's try another one. H of 6. So I go to my h function. 6 is greater than negative 2, so I put 6 in here. I get 3 minus 12, which is 9. Okay, so that's how you do those. These ones are review as well, but here's where we have a piecewise function. So this is what I'm looking for. It says the admission rate from an amusement park are as follows. Children 5 years and under are free. Okay. So if you are 5, 4, 3, 2, or 1, 1.5, you are 0. And then if you are between 5 and 12 years old, you are $10. If you are between 12 and 18 years old, you are 25. So get graph paper out, and I would make, up to $35. So I just went by 2s. And then down here, I made the ages of the kids with 1 square each. It says write a piecewise function that gives the admission price for the given age and graph. So let's actually write a piecewise function. So we have 3 situations. Your output is $0 if your value is less than 5 or 5 years old. Your value is $10 if you're between 12 and 18 years old. It says inclusive, meaning including. If you are, oops, I said 5 and 12. If you are between 12 and 18 years inclusive, then you are $25. So you go to your graph. Like I said, I made another graph going by 2s and then by 1s on the bottom. So I'd go to your graph. If you are 5 years old and younger, you are $0. So $0, 0, 0, 0. So this line's filled in. You don't have to have an open circle because you're just $0. If you are 5 to 12 years old, well, that's confusing. It says 5 years old and under is free. This one says inclusive, so it'd be including, but you can't have that twice. So if you're greater than 5 and 12, okay, if you are 5 years old to 12, that's why I did it here. If you're 5 years old to 12 years old, you're $10. If you are 12 years old to $18, you're here. I would change this because when it says inclusive, you can't include that 12. You can't have both of them be equal to. So you're $10 or $25. You have to be lower than 12. So this is what it would look like. Okay, so this is, because it's going on and on. Adults are 35, so that's why adults are greater than 18. So if you want to try this one out, try this one out. Okay, I'm not making you graph it. We're just completing on your review the rounding up and rounding down function.